Hello, this is Keith Graham from Codasip. Today I'd like to show you two simple techniques that help you parse the instruction that you just fetched from your RISCV machine to parse the instruction into the individual signals that you will be required to implement your 5-stage pipeline. Now, I'm going to use as an example the R-type instruction format. The beautiful thing about RISC-V, if you need a particular bit field, for example, the index into the register file where I'm going to write the result, the RD register, it will always be in the same locations, bit 10 through 14, the source 1, 15 through 19, and source 2, 20 through 24. So for every instruction, if you need that value, you can just extract it from the same location of the instruction. So now how am I going to extract those bits? So I'm going to use the bit extraction technique, which is an open close bracket with two dots. Now, how am I going to write this? Well, first of all, I need to know the name of my signal, what I just read in from the fetch. For this example, I'll just call it R-type. So I'm going to write R-type, and then open bracket, and then the most significant bit, 19, two dots, and that's part of my extraction operator. The lower bit number, 15, and I got my semicolon. That's how you're going to extract that bit field. So there are other times, though, that you need to extract more than one bit field or combine bit fields to generate your signal. And an example of that is the complete opcode. The complete opcode actually for R-type comprises of the function 7 concatenated with function 3 concatenated with the opcode. You will actually need to send that concatenation, the complete opcode, to the instruction decoder for all your instructions. And the decoder will understand whether it needs to look at all 17 bits or not by looking at the unique features or definition of the lower 7 bits, that opcode field. Now I'm going to show you a little technique of using the concatenation with the bit extraction, but I'm going to do a little bit of make it an enhancement where I know that function 3 and opcode are next to each other. So when I do that bit extraction, it can be from 9 to 0 instead of two additional, instead of separating into two different bit fields. Now let me write that. Now I'm going to do function 7, R-type. That's bit 31 through 25. Now I'm going to do my 2 colons. Over here is my operator for my concatenation. And then my R-type bit extraction for 9 through 0. And now I got the complete opcode for my instruction. So that's using bit field extraction and concatenation. There's one more technique I'd like to show you here, and that is sometimes you're going to have to buffer your data by adding some zeros to the right or maybe even in the middle when you're creating your signal. So we have this immediate, which is called 20-bit upper 20-bit immediate. That means the immediate value that we're going to extract will remain in the upper 20 bits. And to keep them in the 20 bits, I need to buffer the lower 12 bits with zeros. So I'm going to do a bit extraction, concatenate it, but buffering with 12 zeros. I do the buffer by doing a typecast. So this is how it will look. So once again, the upper 20 bits of my machine code or my binary would be R-type, the most significant bit 31, and the least significant bit 12. Then I'm going to do my concatenation again, and now I'm going to do the bit or typecast. It's going to be unsigned 12 bits and 0. So that signifies that I'm going to put 12 bits to the right of the upper 20 bits field that I just extracted. So these techniques is what you will be using to parse and create your signals in the decoder field of your decode pipeline. Hopefully this helps. If this video was helpful, please subscribe to this channel so you will be notified on future videos when they are published. Have a great day.